All right, these are some notes on section 5.3. So section 5.3 is talking about linear functions. So a linear function is any function that can be written in the form y equals mx plus b. M is the slope of the function, and b, 0b, is the y-intercept. So we did that on the previous example. We're going to do a couple more. So find the slope of the y-intercept of each function. Write a sentence that explains what each part might mean. So in this equation, y equals mx plus b. So this would be our m, so our slope is 0.05, and this is our b, which is our y-intercept. So our y-intercept would be either 0, 20, or $20. So what that could say is, my cell phone costs $20 per month, plus, I didn't get my plus very well, 5 cents extra for every minute. So that would be a way to write that sentence. On the next example, I have 100 minus 0.8 times d. Oops, this should be 0.8. Okay, so our slope is always the value in front of the variable. So our slope is negative 0.8, and our y-intercept is 100 or 0, 100, depending on the way the problem asks you to write it. So I couldn't quite figure out how to write this one or what to say, but I said something like, my insurance starts at $100 and decreases by 80 cents for every dollar I spend. So something like that. So it's decreasing this time because my slope is negative. Okay. The third example we have here is I equals 0.5% times b. So the slope is 0.5%, which is 0.5 over 100, which is 0.005. And the y-intercept, because there is nothing added or subtracted over here, the y-intercept is 0 or 0, 0 is the point. So I could say something like the interest on the loan is 5% of the balance. So I would do 5% times b. All right. So here's an example, and we talked about this earlier. So the information that you see here represents the population in Houston for the years 2000 and 2010. So in 2000, the population in Houston was 4,715,407. In 2010, the population in Houston was 5,946,800. So they want to know what's the average change in the population over time. So we want to try and figure out, like, how much is the population increasing or decreasing every year. So we're going to do our slope. So this is going to be x1, y1. This is x2. This is y2. So if I substitute this into my slope formula, remember the slope formula is y2 minus y1 over x2 minus x1. I get 1,231,393 over 10, and that would be 123,139.3 over 1. So this number here means that every 1 year in Houston, the population increases by 123,000. Okay, so then it says find the y-intercept. So to find the y-intercept, we have to take the equation y equals mx plus b. This is our b value because that's what we just, sorry, this is our m value because we just got our slope. Our b is our starting value. Our starting value that we have is 4,715,000. So I didn't mean to say that. That is our y value for one of the points. We pick either one of the points that we want. I'm picking this one. So the y value that we have is 4,715,000. The slope is 123,000, and the year is 2000. So if I do my calculations, I end up with b is negative 241,563,193. So this is the problem that we talked about some in the guided workbook also. This doesn't make sense. because this is saying at year 0, the population in Houston was negative 241 million. So first of all, you can't have a negative population. Secondly, it doesn't make sense to talk about year 0. That means not year 2000, not year 1900 or 1800 or 1700, but year 0. So that doesn't exactly make sense because Houston doesn't exist in year 0. So what they tell us to do is to rework the problem when we scale it to since years 2000. So 2000 is 0 years from 2000, and 2010 is 10 years from 2000. So we leave our y values the same, but we change our x values. Our slope doesn't change. But now our y-intercept is that point 0, 4,715,407. So that's our starting value now. That's our y-intercept. So this makes more sense to have 4,715,000 because that's talking about in the year 2000, that was our starting population. So maybe they didn't document something before 2000. Maybe that's the first time that they cared about something and they wanted to document something. It could be that the starting value is not 2000, but maybe the starting value is 1990. What we have here in this problem, those are the only two values we have, so we consider that our starting value. Hope this helps.